Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel, Assistant Professor from LJIT. Earlier lecture we are already discussed about the chain rule and total derivative. Today's session we are going to discuss about the miscellaneous examples of the chain rule and total derivative. Let's see. First example. If u equal to f of x square plus 2yz comma y square plus 2zx, then prove that y square minus zx del u by del x plus x square minus yz del u by del y plus z square minus xy del u by del z equal to 0. In such kind of example, we don't have a function. Then we first assume in this particular example L equal to x square plus 2yz and m equal to y square plus 2zx. Here our function becomes u equal to f of lm. That means we can say that u is a function of L and m and m is a function of xyz. Then u is a composite function of xyz. Then according to the chain rule, we have to finding the values of del u by del x, del u by del y and del u by del z. Now with the help of chain rule, first finding the del u by del x equal to del u by del l into del l by del x plus del u by del y into del m by del x. Now here we don't have the value del u by del l and del u by del m, means we don't have a function. Then that particular value which is kept as it is, and partial derivative of L with respect to x and y and partial derivative of m with respect to x and y, that particular value we substituted in our chain rule. Then del u by del x becomes del u by del l 2x plus del u by del m into 2z. That is our equation number 1. Similarly, we can find del u by del y equal to del u by del l into del l by del y plus del u by del m into del m by del y. Now in this particular chain rule, substituting the values of del l by del y and del m by del y, then it becomes del u by del l into 2z plus del u by del m into 2y. That is our equation number 2. Now similarly, with the help of chain rule, we have to find the del u by del z, that is del u by del l into del l by del z plus del u by del m into del m by del z. Substituting this value of del l by del z and del m by del z, that is 2y and 2x, then our equation number 3 becomes del u by del l into 2y plus del u by del m into 2z. Now substituting the values of del u by del x and del u by del y and del u by del z in our LHS portion, then our LHS equal to y square minus zx del u by del x plus x square minus yz into del u by del y plus z square minus xy into del u by del z. In this equation, substituting the values of del u by del x and del u by del y and del u by del z, then total we have 12 terms. Among this equation, expanding this, and total we have to 12 terms, and among these 12 terms, 6 term which is in form of del u by del l and remaining 6 term which is in form of del u by del m. Then common out the del u by del l in these 6 terms, and remaining all these terms becomes 2xy square minus 2x square z plus 2x square z minus 2yz square plus 2yz square minus 2xz square. Means among this term, 3 term will be positive, 3 term will be negative, and each and every term will be cancel out. Such kind del u by del m, then it is also 6 term, 3 positive and 3 negative, each and every term will be cancel out, then it becomes 0. That is our RHS portion. Hence prove that the given particular example. Now let's see one more example. If r square equal to x square plus y square plus z square and v equal to r raised to m, then prove that del square v by del x square plus del square v by del y square plus del square v by del z square equal to m plus 1 into r raised to m minus 2. Also we can find the nebulous square of v equal to m plus 1 into r raised to m minus 2, where nebulous square equal to del square by del x square plus del square by del y square plus del square by del z square. this such kind of example maybe as in university example sometimes of twisted, maybe as in this form of question or maybe as in this form of question. Answer will be same in both the cases. Just here we use nebula square of v, where nebula square equal to del square by del x square plus del square by del y square plus del square by del z square. Let's see. Here firstly we have to find derivative of r with respect to x, y and z. Then here r square equal to x square plus y square plus z square. Then r is a function of x, y, z, and x and y, x, y and z is a total 3 independent variables. Then here partial derivative of r with respect to x, then 2r del r by del x equal to 2x, and y and z has a constant, then derivative constant, that is 0, then del r by del x equal to x by r. Similarly del r by del y, that is y by r, del r by del z, that is z by r. Now we have to find the del square u by del x square. Then firstly find first order partial derivative, then go for the second order partial derivative, then finding the del v by del x. Then according to the chain rule, v is a function of r and r is a function of x, y, z. See in this diagram, v is a function of r, then v is a function of only single variable, then we use dv by dr, and r is a function of multivariable function, then we use del r by del x, del r by del y and del r by del z. Then according to the chain rule, del v by del x equal to dv by dr into del r by del x. Here v equal to r raised to m, then derivative of r raised to m, that is m r raised to m minus 1. You all are aware about the value of del r by del x, that is x by r, which is already find. Then del v by del x becomes m x r raised to m minus 2. Similarly we can find del v by del y, that is my r raised to m minus 2, and del v by del z equal to mz r raised to m minus 2. Now go for the second order partial derivative, that is del square u by del x square equal to del by del x del v by del x. Substituting this value of del v by del x, that is mx r raised to m minus 2. He in this equation m, which is constant. Now partial derivative of x into r raised to m minus 2, we have apply product rule, u as it is derivative of v plus v as it is derivative of u. Then here x as it is derivative of r raised to m minus 2, that is m minus 2 r raised to m minus 3, and del r by del x plus r raised to m minus 2 as it is derivative of x, that is 1. Now substituting the values of del r by del x, that is x by r, and simplified it, then it becomes m r raised to m minus 2, which is common out, remaining term x square m minus 2 upon r square plus 1, that is our equation number 1. Similarly we can find partial derivative of v with respect to y, then del square u by del x square equal to m r raised to m minus 2 y square m minus 2 upon r square plus 1, that is our equation number 2. Likewise z del square u by del z square equal to m r raised to m minus 2 z square m minus 2 upon r square plus 1, that is our equation number 3. Among these three equations we have to find the nebula square into v, or we can say that del square v by del x square plus del square u by del y square plus del square u by del z square. That means adding these three equations, and among these three equations m r raised to m minus 2, which is common out, and remaining term which has each and every term has a first term which is also common out, m minus 2 into m minus 2 upon r square, then it becomes m r raised to m minus 2 inside the bracket m minus 2 upon r square inside the bracket x square plus y square plus z square. Each and every equation has a second term which is 1, then 1 plus 1 plus 1, that is 3. Now here you know that the values of r square equal to x square plus y square plus z square, then substituting it as r square, then r square which is cancel out, then it becomes m r raised to m minus 2, m minus 2 plus 3, then it becomes m plus 1 into r raised to m minus 2. That is exactly we have to find, or we can say that in form of nebula square, then nebula square v equal to m plus 1 into r raised to m minus 2. Hence prove that whatever the question which is given, here we got the answer. Now Let's see one more example. If r square equal to x square plus y square plus z square and u equal to f of r, then prove that del square u by del x square plus del square u by del y square plus del square u by del z square equal to f double dash of r plus 2 by r f dash of r. Or maybe in university exam some twisted form, means in nebula form, then nebula square of v equal to f double dash of r plus 2 by r into f dash of r. Among these, any question may be asked in university exam in twisted form, then nebula square, in form of nebula square, or in form of simple form. Here in u is equal to f of r means we don't have a function. In our example we already gave the value of function, that is v equal to r is to f. Here we don't have a function. Then firstly we have to find the partial derivative of r with respect to x, y and z. Here equation which is r square equal to x square plus y square plus z square, then derivative with respect to x, then 2r del r by del x equal to 2x, then we get same as above example, del r by del x equal to x by r. Similarly we can find del r by del y and del r by del z, that is y by r and z by r. Now we go for the first derivative, means del u by del x. Then here u is a function of r and r is a function of x. Then according to the chain rule we can write del u by del x equal to du by dr into del r by del x, substituting the values of del r by del x, that is x by r. Then del u by del x equal to x f dash of r upon r. Similarly we can find del u by del y, that is y f dash of r upon r, and del u by del z, that is z f dash of r by r. Now we go for the second order derivative, that is del square u by del x square equal to del by del x into del u by del x, substituting these values of del u by del x, that is x f dash of r upon r. Here x is a function of x, f dash of r that is also function of x, and r is also function of x. Then here we have a total 3 function. Then here we use quotient rule as well as product rule, means x by r that is our one function, that is u, and f dash of r that is v. Then with the help of product rule, u as it is derivative of v plus v as it is derivative of u. Then here f dash of r as it is derivative of x by r, then derivative of x by r, then we apply quotient rule, means v as it is derivative of u minus u as it is derivative of v divided by v square, that is becomes f dash of r derivative of x by r, that is r minus x del r by del x upon r square plus x by r as it is derivative of f dash of r, that is f double dash of r into del r by del x. Now substituting the del r by del x in this particular example, that is x by r, and simplified it, means taking LCM, then it becomes f dash of r inside the bracket r square minus x square upon r cube plus x square by r square into f double dash of r. That is our equation number 1. Now similarly we can find the value of del square u by del y square and del square u by del z square. Then del square u by del y square equal to f dash of r square minus y square upon r cube plus y square by r square into f double dash of r. That is our equation number 2. Similarly equation number 3 becomes del square u by del z square equal to f dash of r square minus z square by r cube plus z square by r square into f double dash of r. Now we have to finding the nebula square into u, or adding these 3 equation, that is del square u by del x square, del square u by del y square plus del square u by del z square. Among these 3 equation, f dash of r which is common out in first term, then it becomes 3r square minus x square plus y square plus z square upon r cube, plus in second term f double dash of r which is common out, then it becomes x square plus y square plus z square upon r square. You all are know about the x square plus y square plus z square equal to r square, then substituting it, then f dash of r inside the bracket 3r square minus r square, that is 2r square divided by r cube, r square which is cancel out, then we get 2 by r plus x square plus y square plus z square, that is replaced as r square, then r square which is cancel out, then it becomes only f double dash of r. Then our equations becomes 2 by r f dash of r plus f double dash of r, or we can say that in form of nebula square v. In form of nebula, the nebula square of v equal to f double dash of r plus 2 by r f dash of r. That is exactly prove that whatever they given the question. Now let's see, if r square equal to x square plus y square and u equal to f of r, then prove that del square u by del x square plus del square u by del y square equal to f double dash of r plus 1 upon r f dash of r. Or similarly same example in form of polar form, some twisted form. Then u equal to f of r where x equal to r cos theta and y equal to r sin theta. Then prove that del square u by del x square plus del square u by del y square equal to f double dash of r plus 1 upon r f dash of r. Here squaring and adding of x and y, then it's become x square plus y square. Then substituting the values of x and y, that is r square cos theta plus r square cos square theta plus r square sin square theta, r square which is common, then cos square plus sin square, that is 1, then it becomes x square plus y square equal to r square. This example which is similarly same in above example, just in form of polar form and in form of Cartesian form. Here this example which is same as in above example has we have total 3 variable, here we have total 2 variable, r square equal to x square plus y square. Remaining all these steps are same, only eliminating the term which is containing z. Try yourself. This is all about the topics, typical problems of the chain rule and total derivative. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this topic, then feel free contact me. Thank you so much for watching me.